Good evening, everyone. Okay, I think we are here. I see some chat messages, and here we have some excellent communications I see. So, let me introduce myself. My name is Valentina Kuskova, and I am here to talk to you about networks. And actually, not just networks, but data analysis in general. So today's presentation is going to consist of two parts. I will talk to you about networks as promised, but I will also talk to you about why it's important to analyze data. And we'll take a look at some of the exciting things, and we'll take a look at some of the things that you can learn with network analysis. So if you have any questions, I understand that you can ask them in the chat room, and you can write them during the webinar. I am delighted to see lots of people here from all over the world, actually, including countries from Russia. And some people are saying привет to us. And so it's wonderful to have you here. And thank you for being with us, spending this evening and talking about networks. Now, I want to ask you a question before we start, because I think it's kind of fun to ask questions, right? So why don't we do it this way? I will share my screen, and we can go ahead and take a look at the question that I want to ask you. Well, the question is not, of course, what is network analysis, but the question is, why did Moscow become the capital of Russia? Please feel free to put those questions in the chat room or in webinar questions. The center where the power is. Somebody says no idea. Because Bolsheviks wanted to move it back, geographic location, economic, mass of power, political reasons. Well, it's kind of a joking question, right? But that's actually an interesting question at the same time. There are many answers. Oh, here's one that I like. It says transport. This is an old map. You can probably notice that it's made many, many years ago. Here's the link. So when you're watching this, you can take a look at this. So this is a map of old Russia, but notice it doesn't look very usual. It's the map of Russian rivers. So actually, the network's answer is the best answer. Because if we draw this as, correct, trade routes, if we draw this as a river map, rivers were the method of transportation at the time. And the most shortest paths went through Moscow. So that means that Moscow was connecting all other parts of Russia together, which what we call in networks is betweenness centrality. So Moscow had high betweenness centrality. It was in the middle of everything. Therefore, it became the capital. Now, maybe that's true, maybe it's not. This is published work, so you guys can question this somehow if you want to, okay? Now, here's something else that I suppose you all know. You've heard of 6 degrees of separation, right? Have you? Somebody? Of course, okay, well, that was kind of, well, some people have said they haven't heard. Well, for those that haven't heard, I will actually talk about it a little bit. So it all started with the 1929 articles. I think it all started because that's how far I could trace that history. Maybe it started earlier than that. On this slide, you will have a link to the article and you can read it. Actually, Michael was, we are arguing energetically about whether the world is actually evolving. It's 1929, right? So here we are 100 years later and we're talking about the world evolving. But okay, that's not the story what it's about. That's about. In 1967, Stanley Milgram conducted the actual 6 degrees experiment. Here's what he did. He took letters and send them to people, asking them to send them to other people who might know someone else. And then at the end of the day, the letters that he sent to particular people without an address have reached their addressees, having been through 6 or 7, maybe sometimes 5 different hands. So basically, now that we live in a much more connected world, right? Facebook says, well, at 6 degrees is now 3.57. What's the degree of separation? That's the links between you and the next person. So at the times of Milgram, 1960s, 1970s, that was about 6. Now they say it's about 3.57, and that's the Facebook research 5 years ago, when Facebook had about 3.54 billion users. Now, I mean, I'm sorry, 1.6 billion users, when we're around 2 degrees of separation. And if everyone joins Facebook, we're going to have less than 2 degrees of separation. So you'll practically be connected to the rest of a friend. So networks are all around us. And since I'm in Moscow, of course, I'm talking about Moscow. Subway. Moscow has an excellent system of transportation. Those of you who are thinking about joining us, perhaps for an offline version of this program, you are very, and you will learn the map of transportation very easily. But map of transportation is actually a network. And it's drawn like this. We're used to this map. What if it were drawn like something like that? This is the exact same map, but now it looks like a network, right? Well, and the it's very easy to find so many dots because what is a network? Okay, let's take a look at what is a network. And here I'm going to actually draw a little bit. If you allow me, I'm actually a horrible drawer, but I love to do that. So let's think of someone, a person, okay? And this person, we'll call this a person A, okay, is connected to someone whose name is B. Well, this person A is also connected to someone whose name is C. B and C did not know each other. To B. A is connected to C. How soon do you think there will be a path between B and C? Do you think they will ever get connected? Chances of random meeting between B and C, let's say in the city of Moscow that has a population of about 12 million, is very, very low. Think about it, just 2 random people. But if these 2 random people know A, how much sooner do you think they will connect? So what I have drawn for you is a simple network. These little guys, A, B, they're called nodes. And the connection between them, including absences of connections, are called links. So we can draw these nodes and links and paths between them because C has his friend, and they all, and what we call them in network a standard deviation, right? And that's S because this is a sample. And we know there is a difference between the sample and the population. And then we can maybe calculate, a relationship between two variables. We have an X bar and Y bar. And before we know that, we can start building regression equations through that line of data. I'm not drawing very accurately. On these attributes, right? Now imagine if these dots are actually connected with each other. Analysis that I just showed you, some simple calculations of average, else, nodes are independent. In fact, independent, identically distributed. This is actually a demand of many parametric methods of data analysis. What these methods ignore is the fact that our dots are connected. And network analysis studies these connections and can actually see the influence that node A has on node B, and node B has on some other node, and how these influences actually change the attributes. So then A are going to propagate that same regressions that we do, factor analysis, structural equations modeling, machine learning, if you want. We can do all of those simple and complex methods, but together with networks, we are learning something that's relational. So what's a network? A network is a set of connections or relations between data that we analyze anyway. We take those nodes and ties between them. We use all the information about the nodes and ties, and we analyze them somehow together. This analysis is applicable everywhere. I mean, yes, everywhere. I have not found an exception to the method of using networks. I don't know of any problems where network analysis cannot be used. So where can it be used? It can answer questions about power, status, and rank. Why, if you know the last name Medici, I'm saying Medici, you have heard of them. I'm not sure where you've heard about them, but I know why. Because in the 15th century Florence, and this is a classical network analysis problem. When you study networks, you study 15th century Florence. In the 15th century Florence, Medici were not the most powerful, they were not the richest, they were just simply the most connected. Now, motivation. Why do some people study at school and some do not? Or why do some people work hard and others do not? As a university professor, of course, I know that my students have different personalities and my classes have different personalities. I might be teaching the same class to two different groups at the same time and get completely different response to the same lecture. Well, that's because group dynamics matter, and student motivation often depends on what other students in the group do. Now you can study communities, how communities form and how they dissolve, and what happens with a community altogether. Whether or not some diseases can spread altogether. We know all about COVID, right? Effectiveness.